Shall I start, sir?
Yes, sir. Please, sir.
Yeah. Good evening, students. Now, in today's class, let us start very important subject in civil engineering. That is reinforced cement concrete. Simply, we can say RCC. And we can say this is a very important subject for civil engineers. So you choose any kind of profession in civil engineering, mostly you come across this subject. Whether it may be any kind of profession, it may be teaching or industry, whatever it is, and any competitive examination you write. So this has a good weightage basically. And if you look at gate examination point of view, the weightage for this is RCC is around 6 to 7 marks. That is the maximum marks I can say. Then if you look at engineering services examination, the weightage for this subject is around, you will get around 80 to 90 marks. So that means including objective and conventional together, it has a weightage of around 80 to 90 marks. So that's why every student has to pay more attention towards this subject. And if you want to do some consultancy on your own, then also this is a very, very essential course as far as structures are concerned. Most of the structures you look at outside, including your building where you are staying at present now, are nothing but made of reinforced cement concrete. So what is a reinforced cement concrete? So we'll look into it first. And why we have to go for reinforced cement concrete? Why not steel structures? Okay. And what are the basic properties of concrete? Because before going to know about RCC, we're supposed to know about what is the concrete basically, and what is the composition of concrete. Then they're asking very basic questions from these concrete fundamentals also. So this course I will be teaching you very clearly in a simple manner, and I will be teaching you shortcuts wherever it is required. And you try to focus on the content, whatever I'm delivering. That is more than sufficient for any competitive examination you write. And the thing is that for this subject especially, you need to have proper continuity. It is not like other subjects. In this subject, you need to have continuity because every chapter is interlinked. Basically, especially the first 5 classes, whatever I'm going to take, those are very, very important. And once you are very thorough with those 5 classes, whatever I'm going to take, then you can literally play with this subject. It's a very, very simple subject when you are clear with the fundamental concepts. Okay, so that is what I am trying to say. Then let us see what are the weightages for different exams. I told you for the gate exam, it is a maximum of 6 to 7 marks. And engineering services, I told 80 to 90 marks, including objective and conventional together, right? And if you look at here, we have even, in addition to reinforced cement concrete, we have pre-stressed concrete also in addition to this. And for from this, every year you are getting 2 marks in the gate examination. And other competitive examination also, good amount of weightage is there for this together, RCC as well as PSC. PSC means pre-stressed concrete. It is the pre-stressed concrete. It is something different from RCC. RCC is different. And here PSC, pre-stressed concrete, generally we use for most of the bridge construction. Now almost everywhere we are using this pre-stressed system. We have pre-tensioning, post-tensioning, like that. So I'll explain whenever I start this separately. I'll explain this, but first we complete the reinforced cement concrete. It's a very big course. Then after that we'll be looking into PSC also. For this exam, we have both together, RCC as well as PSC together we are having. And now look at the syllabus for the gate examination and other competitive examination, engineering services, and you write even state level competitive examinations also. So there is a good amount of weightage for this course, reinforced cement concrete. Let us see the contents of this reinforced cement concrete. If you look at first thing is that you will be having fundamentals of concrete basically. So we are getting at least 1 or 2 marks from this. Fundamentals of cement concrete, we can say concrete basically. So you will be getting 1 or 2 marks from this every year. It's a very, very important thing, basic thing before going into reinforced cement concrete. And after that, you have something called methods of design of reinforced concrete structures. What is RCC? Then we have methods of design of reinforced concrete structures. we have basically different methods. We have working stress method, we have limit state method, and we have ultimate load method. There are three methods are there for design of reinforced concrete structures. And for your examination, so you will be focused onto the limit state design. Most of the time at present, all the competitive examination, the syllabus is based on the limit state method, because working stress method and ultimate load method anyhow we are not going to use, but this is one of the method which is existing but we are not using at all. But working stress method we can use because of the safety concerns. Wherever there is a safety is required, we go for the working stress method. I'll explain this philosophy of these methods very clearly. Just I'm writing the syllabus for the competitive examinations. Okay. Now, if you look at methods of design, then after that we'll be looking into completely limit state method. Basically, our entire syllabus is based on limit state method. We have several methods, but as of now, we are using limit state method of design of reinforced concrete structures. As per the provisions of IS 456-2000, this is the code for design of reinforced concrete structures. IS 456-2000 is the code for design of reinforced concrete structures in India. Okay, any reinforced cement concrete structure you want to construct, basically, this book is going to give you guidelines. Each and every parameter will be written in this code, and you have to follow whenever you design any structure. Basically, you have to look into this code, and you should not violate from this code. If you are violating from this code provisions, then you will be punished. Basically, that is what. So it is very, very important code for the civil engineers, and it is going to change in the next year. I think we will be having another code, but as of now we are going to still we are using 2000 version only still. Then in limit state design, if you look at your syllabus, we have basically, can you please tell me what are the structural members we are having? Can you please tell me what are the different structural members we are having? Look at your building.
How many? Columns, beams, arches.
Yes, very good, excellent. So we have beams, we have columns, we have slabs. So if you come from top, we'll be having slab on the top, and we can have below that beams. Then we can have columns. Then at the bottom, we'll be having foundation or footing, we can say. That is what the basic structure is, basically. If you look at any residential building. And we have bridges also, that's different case. And we have even arches. They generally we use arches for bridges, basically. It is not for residential purpose, right? You know that. So now, if you look at our syllabus for any competitive examination, basically, this is basically design of members only. So in RCC, we'll be designing the members, structural members. The structural members are basically, what are the structural members? Can you please tell me? Structural members. Any structure we are constructing, it is nothing but summation or joining the different structural members only. Look at beams. We have beams, we have columns, we have footings, we have slabs, basically. Beams, columns, and footings. This is what our entire syllabus for the examination is. So, but here beams plays a vital role. That's why we will be starting with the beams. You look at any syllabus, they will be giving you first beams only, because in beams you will be learning all the basic stuff, basic important concepts for design of structures. You'll be learning from the beams. That's why. So we have the first chapter, in the syllabus. The first thing is that the design of singly reinforced beam. So how to design design of singly reinforced beams? That is the first chapter for us. After these things, these are the very basic things. First, we start these things today. Then after that, we'll be starting the limit state design of design of singly reinforced beams. Then we will be going for design of doubly reinforced beams. Then after that, we will be going for design of these particular beams. But we can have continuous system. For example, look at function hall. Look at a function hall or library building. Those are very big buildings. Basically big halls and all, function halls and all. We'll be having large space. So can you expect only one column in the 2 columns, 4 columns like that? No, there are several beams, several columns are there, because it's a big hall or whatever it is, function hall, library building, etc. In such case, we'll be having many number of beams and columns. So continuity of slab is there over the beams. That's why the beams are called as the flanged beams. What we call them as flanged beams. So how to design flanged beams? we'll look into it. Flanged beams means we have T beams, L beams. These are basically called as the flanged beams. How to design these beams, we'll see. That is what our third chapter is, basically design of flanged beams. Then the fourth chapter is design for shear, limit state design for shear. Then after that, limit state design for torsion. We'll be looking for how to design RCC member for torsion. Then I'm writing here, the sixth chapter will be how to design an RCC member, which is basically subject to compression. So we'll be designing compression members, especially columns. How to design the compression members, we'll see that. So we have long columns, short columns, how to design those long columns, short columns, and what are the formulas basically used to estimate the load carrying capacity of RCC columns. Then after that, we'll be going for design of slabs. How to design the slabs. We have different types of slabs. We have one-way slab, two-way slab. How to classify one-way slab, two-way slab. Okay, what are the parameters that we have to consider for the design of slabs? So we look into it very, very clearly in the subsequent lectures. Then we have a design of footings. How to design the footings? What are the different types of footings we have? And what are the minimum recommendations for edge thickness of for the footing? And what is the one-way shear? What is the two-way shear? We'll be checking all those things. How to design the footing for bending and shear. So we'll see those things very clearly. Then after that, we have limit state of serviceability. So whenever you construct a structure, basically, that structure should not fail by serviceability aspects. What is the meaning of serviceability? Can you please tell me? So serviceability means basically deflections, cracking. These are the basic serviceability aspects. So there are two criteria. One is the strength criteria. The second one is the serviceability criteria. So structure may fail because of weakness, because of lack of strength. That is what we call the strength criteria. The other thing is because of some aspects of deterioration. There may be cracks. There may be kind of deflections because of material, imperfections and all. So those things comes under the serviceability. So basically, we design any structure for the strength aspect, but we check for the serviceability aspects. Okay. So major serviceability criteria is deflection. What are the major serviceability criteria? Deflections. Then after that, we have cracks. So the RCC member, whatever we design, any member you take it in your building, you have a slab. Look at top, you will be finding a slab. Slab should not get cracks. If the cracks are there, it is going to fail. Obviously, not immediately, but after a few years or a few months or a few days, it may fail. So that should not happen. Being a civil engineer, once you construct any structure, it should not fail in strength aspects. It should not fail even in serviceability aspects. That means the member, whatever you design, should not fail by excessive deflections. We have to find appropriate material, appropriate arrangement of reinforcement, and appropriate material composition for the concrete. Then after that, you have to see that the stiffness of the system, whole system, supporting system and all should be very, very, stiff enough in order to avoid the deflections. Okay, that is a very important deflection. Then after that, cracking, right? So these two things we'll look at very clearly. What are the provisions for crack width? What are the maximum crack width you can allow in an RCC structure? What are the maximum deflection that you can in an RCC structure, like a slab? What is the maximum deflection? For beams, what are the maximum deflection? So all these criteria are very clearly given in our IS 456-2000. Now, after that, after this limit state of serviceability, we will be even checking for bond. What are the checks that are to be done for bond? Okay, so that I'll explain very clearly. Listen, can you please tell me what is reinforced cement concrete? Can you please tell me what is reinforced cement concrete? Look at basically when you look at, I think you might have already seen any kind of structure construction. You'll be using concrete, but before placing the concrete, we'll be providing steel bars. So if you embed steel bars into the concrete, then that concrete itself is called as the reinforced cement concrete. Fine. So listen, how all our buildings are able to sustain. People are able to construct now, nowadays recently, we are going for 50, 100 floors also, most of the commercial buildings basically. how your building is able to sustain such a big number of loads. Every structural member is very strong enough to withstand all the loads acting on it. Why it is so? Because of the reason is that bond. If the bond is not there between concrete and steel, then RCC is a useless thing. So very, very important parameter is bond. If bond is not there, then we cannot go for reinforced cement concrete. So bond plays a vital role. If bond failure happens, even though you are an excellent designer, it is of no use. Okay, it becomes a waste material, we can say, right? So bond criteria is very important. Whenever you design any RCC member, we need to ensure that there is a proper bond between concrete and steel. For that, there are some checks are given by Indian standard that I'll explain very clearly how to check any RCC member for bond. We'll see that clearly. Then after that, this is our entire syllabus for the examination. Then one more important thing, especially gate examination, then come to the another topic called as pre-stressed concrete. That's all. This is our syllabus, but all these members we design as per the LSM. LSM means limit state method. Then now you try to understand, dear students, we have one more part called as pre-stressed concrete. Okay, so that is dealt separately. We have two types of pre-stressing systems. We have pre-tensioning, and we have the second thing called as post-tensioning system. Just I'm giving brief idea here, but after that I will be explaining you one by one very clearly. We have pre-tensioning system, and we have even post-tensioning system for these, especially pre-stressing systems. We have these two, but mostly we will be using post-tensioning system for structures, and pre-tensioning generally we use for railway sleepers, electrical poles, etc. Very, very small limited applications are there for pre-tensioning system. Okay, so just I'm giving a basic idea about the whole syllabus so that you have some idea before I teach any subject. This is what I follow, so that the students will be knowing what is the content I'm going to teach after this. Okay, so it is a brief summary of our course, reinforced cement concrete. And I can say this reinforced cement concrete is heart for civil engineers. It's a very, very important subject, I can say. It's a heart of civil engineering. Okay, RCC course is called like that because without RCC, no structure is there nowadays. So anyhow, we are going for steel structures. That's a different case, but we cannot go for steel structures for every structure. It is not possible, and it isn't possible, but uneconomical. People not in a position to bear that much amount of money because steel structures are a little costlier when compared to reinforcement concrete. Fine. Now let us come to, so as you know, what the methodology, what I follow is, I ensure that my students has to learn the fundamentals very clearly. So that's why I'll start the course by giving you the basic introduction to the each and every parameter. Then after that, I'll be getting into the design. So in today's class, let us first focus on to the fundamentals of concrete. What are the basic fundamentals of concrete? What is a concrete? What are the mix? What are the different types of mixes we are having for concrete preparation? And what are the what is the meaning of characteristic compressive strength? What is the meaning of target mean strength? What are the standard deviation? So let me explain all those things very, very clearly. Then we'll be going to the design part. Is it fine? Any questions as of now? Any questions from students? Is it clear to everyone? Yes, any one of you?
Yes, sir.
Yes, sir.
Okay, fine. So you will be scoring these marks, no doubt, provided that you don't miss any class. Okay, you should be there in the class so that you can score those marks comfortably. So now let us see the basic fundamentals of concrete. So can you please tell me what is a concrete? As every one of you might be knowing, but let me tell you anyhow the fundamental things, because the questions are being asked from this area. At least 1 or 2 marks you're getting every year from this concrete fundamentals. Okay, fine. Let us see what is the concrete basically. So concrete is a mixture of, can you please tell me what is this? Concrete is a mixture of
Cement, fine aggregate and coarse aggregate, sir.
Yeah, it's a mixture. Very good. It's a mixture of cement plus fine aggregate plus coarse aggregate. So can you please tell me what is the function of cement in concrete basically? Can you please tell me in a brief what is the function of cement? if you add these three and also water, we should not forget that, right? So there should be water, otherwise we don't get concrete. So we have even water. So concrete is basically a mixture of four materials, that is cement, fine aggregate, coarse aggregate, and water. So what is the function of cement in concrete? Listen, whenever people says that concrete is nothing but a curry, but the ingredients are cement, fine aggregate, coarse aggregate, and water. So how to get a good taste when you prepare any curry? So appropriate proportion of ingredient we have to add, otherwise it becomes a tasteless. So here also we need to mix cement, fine aggregate, coarse aggregate, and water in such a way that you should get the real taste. The real taste is what for concrete? Strength, basically. Strength is the real taste for the concrete. Okay, that's what the thing is. So we will be measuring the concrete ability in terms of strength. It can be compressive strength, it can be tensile strength, flexural strength, whatever it is. So proper strength of concrete is achieved by placing the proper material composition. So basically, how much cement we have to add, how much fine aggregate, how much coarse aggregate, and how much amount of water. But listen, if you are adding these things, why not other things we are adding here? We're not adding other things to get concrete, right? As we know that. We are adding these materials only. That means every material has some contribution to the concrete. So what does cement do to the concrete? Can you please tell me? What does cement do to the concrete? It do what? Cement is...
It gives the binding property, sir.
Yeah, cement is acting as a binding material. It gives the binding property. Okay, so because the thing is that the cement has both cohesive and adhesive, both properties. Cement has both cohesive and adhesive property. What is the meaning of cohesive and adhesive? Cement has both cohesive and adhesive property.
So same molecules are attracted means cohesive, sir. Different molecules getting attracted means adhesive.
Yes, very good. So cement has both cohesiveness and adhesiveness. What is the meaning of cohesiveness? The attraction between the same particles, same material. So cement bond together. That's why we can have cement paste. Okay, cement paste. If you apply, look at your plastering in your building. So we do plastering with what? Cement and sand will be mixing and water will be adding. Cement and cement are sticking together, right? Basically, so that is what we call cohesive property. What is the meaning of adhesive property? Cement is actually bonding with the reinforcement also. Cement paste is actually bonding with steel bar. Cement paste is able to bond with the brick material. It can be steel masonry also. We'll be using cement mortar, right? Cement has sticky property that has it in terms of same material bonding, as well as the other material. When you actually add to another material, it is going to stick to another material. That is what we call adhesive property. Okay. Then it has both the properties. That's what you have to understand. Then the other thing is that we have fine aggregate. What is the function of fine aggregate in concrete? Can you please tell me what is the function of fine aggregate in concrete? Listen, what is the fine aggregate? Can you please tell me? How do you technically define
it is used to fill the pores.
Yeah, fine. What is that? We can say exactly. Yes, correct. It is going to act as a, we can say that void filler, basically. What we can say? Fine aggregate is going to act as a void filler. Fine aggregate act as a void filler. All the voids in concrete are filled by the fine aggregate. Generally, we are going to use sand as a fine aggregate. So generally we use sand as the fine aggregate for our concrete preparation. So earlier people used to use some other materials also. Surki, that means when bricks are burned, overburned, there is a powder that is there on the top surface. That is what we call surki. People used to use surki as also fine aggregate earlier, but the recommended thing is that sand is basically, it has appropriate silica content and all, which is very essential for appropriate strength gain and all. And it is inert material. We have to go for inert sand, basically inert material. And one more thing is that to call a material as a fine aggregate, it should pass through the 4.75 mm sieve. So the material which is passed through 4.75 mm sieve is called as the fine aggregate, which has a size of less than 4.75 mm. It is passed through 4.75 mm, right? Now coming to the other point, what we call coarse aggregate. What is the function of fine aggregate? All of you, it acts as a void filler in concrete. Basically, see. Okay, Alex, let me explain coarse aggregate. What the coarse aggregate is basically the material which is basically having a size more than 4.75 mm. That means the material which is retained on 4.75 mm sieve and passed through 70 mm is basically called as the coarse aggregate. So generally we use granite stone chips. Granite chips, they're made into cut into pieces, fragments, you can say. Those are generally used as the coarse aggregate basically. But the thing is that their size should be more than the 4.75 mm. Then those materials basically called as the coarse aggregate. And coarse aggregate, different types are they available. I know basically if you want to have more workability, we need to have rounded aggregates. So okay, I'll explain that. That will be there covered in building materials. That's not that. Let us not go into detail into those. But what are the technical things which are required for RCC? I'm explaining here, and you have separate course called building materials. So there it will be explained very clearly. Fine. Now come to the point. What is the function of coarse aggregate? Why we need to add coarse aggregate for the concrete? I told you everything contributes something to the concrete. Cement contribution is it has binding property and it has cohesive property, nothing adhesive and all. And also one more thing is that cement has micro filler. It's a very fine material. Most of the cement particles are having size less than 90 microns, and some of the particles may be even less than 75 micron also. But so they also act as the micro void fillers. Cement also act as the micro void filler. So small micro voids are filled in the concrete by cement particles basically. Now another thing is that we're talking about coarse aggregate. What does the coarse aggregate do? Can you please guess? Strength contribution. Strength to the concrete is basically governed by the coarse aggregate. Strength attainment of concrete is basically dependent of coarse aggregate. If coarse aggregate is not there, then the concrete, we never call it as a concrete, we call it as a mortar. What we call it as? Mortar. If coarse aggregate is not there, if you mix cement, sand, and water, it becomes a mortar. But we are talking about concrete. Concrete essentially has coarse aggregate. And what is its function? Strength. So if coarse aggregate is missing, you cannot get more strength. Highly impossible. You cannot go for higher strength concrete without coarse aggregate. Mortar, especially you take it, mortar has limited strength because it has only cement and sand, but no coarse aggregate. That's why it has very limited strength. Mortars, otherwise we cannot build, we can build all the structures with mortar only. Why we are going for coarse aggregate? Because in that concrete, especially any structure you construct, the structure should have sufficient strength to withstand the loads and all. That strength governing parameter should be, it is proved already, it is a coarse aggregate. Okay. Now, what is the function of water basically? What is the function of water in concrete? Can you please tell me? What is the function of water in the concrete? Basically, it is going to give us workability. What is that? Workability. So workability of concrete is basically governed by the what? Water. Workability as well as hydration. Hydration means strength attainment. So cement particles basically requires water in order to get hydrated, and because of hydration we get CaSH gel. Because of hydration you get calcium silica hydrate gel. It is possible. Hydrate means water. Calcium silica both are present in cement. These are present in cement, calcium and silica. But hydrogen molecule, water, you take, what is the chemical formula for water? H2O. That H2O, that H is going to interact with this and it is going to form CaSH gel. That is basically contributing to the strength to the concrete. Strength to the cement mortar is basically governed by the CaSH gel formation. Okay. So water is essentially required in order to get the strength attainment of concrete and also workability. Can you please tell me what is the meaning of workability? What is the workability? A very
Easy to work, sir.
Yes, very good. The simple word we can say is to work. What is the meaning of is to work? That means easily the concrete should be mixable. Okay, easily it should be able to transportable from one place to another place, and the concrete should be easily able to place in the formwork. So look at whenever you construct any structure, basically there is a formwork they construct. For example, look at columns. There will be some kind of, you will be finding very clearly why I'm selling columns is because they are having some height. You can notice them very clearly. You might be finding how do you pour the concrete in vertical? Can you pour like that? Just like that? No, we'll be providing some, kind of farm work. It may be wooden farm work, it may be steel farm work, it may be aluminum farm work, whatever it is. Then we are going to pour concrete into it. So that concrete has a plasticity property. You know that concrete has plasticity. Do you know what is the meaning of plasticity? Can you please tell me what is the meaning of plasticity? I'm not asking plastic, but I'm asking about plasticity. What is the meaning of plasticity? Can you please tell me? What is the plasticity? Plasticity means what? Moldability. So you pour the concrete into rectangular box, it becomes a rectangle box. Something like a doll. If you want to prepare a doll, with mud, you take sand or clay for the preparation of, let's say, any doll. In your childhood, you might have played. Do you take clay
Clay, sir.
or sand?
Clay.
Clay. Why? Clay is having plasticity property. What does it have? It has a plasticity. That means, what is the meaning of plasticity? Plasticity means moldability. So once you mix clay with water, it has some consistency. Then it also has sticky property. That sticky property is there anyhow. At the same time, it has plasticity, means moldability. We can mold that material into required shape. So whatever the shape you want to mold it, you can mold it. That's what we call plasticity. I'm talking about, not plastic. I'm not talking about plastic material. I'm talking about plasticity. So plasticity is a property of a material which can be converted into any shape, whatever you want, by molding into it. Okay, by placing into one container, by hammering it into something like that. Okay, that's what we call as plasticity. So concrete is having plasticity. That's why you'll be able to find rectangular beams, rectangular columns, circular columns. Why you're getting circular columns, rectangular columns? How you're able to get all these shapes? All these shapes were able to get because of this moldability property of concrete. That's what we call, technically we call it as the plasticity. Okay, so concrete has plasticity. Let me write that here so that you can understand easily. Let me tell you, concrete has plasticity when it is in fresh state. So concrete has plasticity. Concrete has plasticity when it is in fresh state. When it is in fresh state. Fresh state means if it is mixed fresh recently, then it has plasticity. But once the setting is over, after setting is done, then cement loses completely plasticity. What is the meaning of final setting time? There are two types of setting times we're having: initial setting time, final setting time. So when I say initial setting time means it is the time at which cement starts losing its plasticity. So whenever you mix water to the basically all these mixtures, cement, fine grade, coarse grade, and water, when you add water to the cement, then after some time the cement has moldability property, but after some time the cement start losing its plasticity. It start losing. Whatever the time at which cement starts losing its moldability property, the starting time of losing plasticity is what we call initial setting time. What is the meaning of final setting time? Final setting time means it is the time at which cement completely already loses its plasticity. So by the time of reaching the final setting time, cement completely loses its moldability property. That is what we call, it becomes a non-plasticity material. We cannot mold after final setting time. I hope you understand what I am trying to say. That is what we call final setting time. Okay. So that is what you have to understand. So that means concrete is having that plasticity property when it is in fresh state. Please remember this one. Now the other thing is that we have, okay. So can I tell you the cement manufacturing process and all, or we'll directly go to the concrete alone itself. So that's what. Are you aware of cement composition and all? Yes. What are the box compounds? So I think you might be having some idea about all these things. Otherwise, you will be learning all these things in building materials once again. So let us completely we'll go towards the our reinforced cement concrete. Okay. So let us not discuss those cement if you want, I'll explain. That's not a problem. We'll see that in building materials. I'll explain those things in building materials. Fine. Now let us come to this. We have something called as. So do we need to explain the standard consistency and all? Just let me think for a minute whether to teach you all those things or directly can go for concrete fundamentals. Okay, that material part we'll see in building materials. I'll be teaching that course also. That's not a problem. Is it fine? So do you want me to explain the cement, all these material properties, or you want to learn in building material directly? Any one of you? Is it fine? Can I teach you those things in building materials? Because building materials separately we have cement, all these material properties, separate courses there. So let us not waste that time by spending here. Anyhow, I will be teaching there. That's not a problem. Now let us understand what are the very important things that are required for the concrete. Okay, what are the basic requirements? Let us look at that. So first thing is that we'll be looking for cement. Okay, let us see the cement. What kind of cement we need to use basically? So cement, we have three grades. Let me explain that here just to have some idea. I'm explaining this. Cement has, what are the meaning of cement? Nothing but ordinary Portlands. We call it as simply OPC. Cement or ordinary Portland cement, OPC. It has three grades, OPC 33 grade cement, and we have OPC 43 grade cement, and we have OPC 53 grade cement. So there are three grades of cement we are having. These are the three grades we are having, 33, 43, and 53 grade. Now you try to understand, dear students, this number, whatever the number we are having, that number itself is the strength of the cement mortar. Okay, cement does not have any strength by alone. That's why we are mixing all these things. If cement itself is having strength, why we use all these things? So cement is a powder basically. It does not have any strength. So basically, when you want to test the strength of the cement, you cannot test the powder. How do you test the powder? If you apply load on a powder, it will go. That's all. So powder, we cannot test. That's why we take the help of sand basically. So that's why we prepare mortar. What is the meaning of mortar? Can you please tell me? Can you define a mortar? Mortar means it is a mixture of cement, fine aggregate,
and water.
Yes. Not coarse aggregate, fine aggregate and water. Cement, fine aggregate and water. Fine aggregate means sand. So cement, sand and water, if you mix them, then whatever the mix we are going to get, that is called as the mortar. Because we are using cement as a binder here, that's why it is what we call cement mortar. If you use lime, then it becomes a lime mortar.
Lime mortar.
Yeah. And we can have gauged mortar. That's a different thing. Those are, we will be using cement, lime, and all this thing together as a binding material. Then that is what we call as gauged mortars. That is a different thing. You can learn all those things in building materials. Fine. As of now, you try to understand. We'll be focusing on cement mortar. Cement mortar, nothing but cement mixed with fine aggregate and water. Now, our Indian standard is saying that whenever you want to test the grade of the cement, we have to use a standard sand. What sand? This fine aggregate should be a standard sand. The standard sand is basically you'll be getting from Tamil Nadu itself. So there's a place, I think you might have heard about that place in near Chennai city, I think, near Chennai city. There is a place called as Ennore. Yes, you might have heard about it. So NO sand we are going to use as the fine aggregate. So NO sand, that NO sand is used for getting the strength of the cement mortar or cement basically. So this, why NO sand is recommended by Indian standard is that because the NO sand is found to be free from organic matter. It is free from organic matter. It does not have impurities which are going to influence the property of the cement. That's why people use no, our Indian standard itself is recommending to go with the NO sand, which is free from organic content, which is an inert material, which is not going to affect the chemical composition of cement. Okay, that's why basically this sand is called as the standard sand. The standard sand only we have to use in order to get the grade of the cement. Suppose, listen, you are a civil engineer. Somebody came to you and asked you, some cement sample is given to you, let's say. Some cement sample is given to you from a bag randomly. And the people are asking you to decide the grade of cement. How do you decide the grade of cement? There is a methodology, there is a procedure. The procedure is that take the cement and mix that cement with the NO sand, which is a uniform sand, in the proportion of 1:3. What is the proportion of cement and sand for a mortar, standard cement mortar? 1 part of the cement we have to mix with the 3 parts of the fine aggregate. Then we need to add a water, and the amount of water to be added is given by P by 4 plus 3% of water content. We need to add that. So that amount of water is very, what we can say, standard. No, we can say that standard recommendation given by Indian courts, and we are going to use that. Okay. So P by 4 plus 3% by weight of the cement and sand. What is the P there? Standard consistency. So what is standard consistency? Standard consistency means how much water we have to add to cement to prepare a cement paste. For example, you take 1 liter of cement, 1 kg of cement to take it, you put 1 ml of water. Can you get a mix? To take 1 kg of cement in a container, you place only 2 drops of water. Do you get a mix? Can you mix them? Impossible. Impossible, right? If you take 10 kg of cement, if you add 100 liters of water, how many liters? 100 liters. Take only 1 kg, let's say 1 kg, for example, 1 kg of cement and 100 liters of water. What happens? Do you get a mix or liquid? It becomes a liquid. It becomes a liquid. So listen, to prepare a cement mortar, which is of having good consistency and good strength, for that we need to add some amount of water. That amount of water in percentage by weight of cement is what we call as standard consistency. You understand what the meaning of standard consistency? How much amount of water we have to add to the cement so that the cement will not behave like a liquid and the cement will not behave like a stone. It will be like a consistable, flowable, mixable. Okay, that's what, that kind of thing is what we call consistency. Okay, so for that, how much amount of water is required for getting the appropriate consistency is called as the standard consistency. So that's what you have to understand. Okay, so that is a very, very important test. You might be doing that in the laboratory. You might have already done, isn't it? Yes or no? Have you done it or not? You might have done that standard consistency in your lab. We are using operators called as YCAT operators. Have you did it or not?
Yes, sir.
Yes, yes. YCAT operators we use to determine standard consistency of cement. Now listen, okay, let's not worry about that. And let us go forward. So we have different grades of cement. Do you think that why these 3 grades, why they're, do you think that they're having same strength? 33 grade, 43 grade, 53 grade. Do you think they have the same?
Sir, no, sir.
No.
No, sir.
Sir, the grade number indicates the strength in 28 days, sir.
Yes, very good, very good. So this number itself is indicating the strength in 28 days. Why 28 days? Why 28 days? Why not 90 days? Why we are testing any specimen in laboratory for 28 days? Our Indian standard is saying that the curing of specimen. What is the meaning of curing? Can you please tell me what is the meaning of curing? So curing means,
Sir, watering it, sir. Watering the concrete or cement, sir. Cement surface.
Yeah, correct. So what is the meaning of curing is, so if you are able to supply enough amount of water to the cement particles, then we can say that the cement has the ability to form CSH gel. So the CSH gel, that means calcium silica hydrate gel, if it has to form, there must be some amount of enough amount of water should be there, okay, to form the CSH gel. Then only the cement will be able to attain appropriate strength. So that enough amount of water to the cement basically can be achieved by curing for 28 days. How many days? 28 days. It is proved experimentally. Many people have done research and they concluded that for the cement, if you are able to supply 28 days of water continuously, then that cement will completely gets hydrated and it would be able to give enough strength. Okay, I hope you understand this. Is it fine? Right, 1 minute. Any question as of now? Do you have any questions?
No, sir.
Fine. So it is proved that almost 95% of cement gets hydrated within 28 days of curing. That's why all specimens in laboratory, any cement concrete, it may be cement mortar or cement concrete, whatever it is, if there is cement, basically we have to cure that for 28 days. Curing means supplying enough water to the cement particles. That process is called as the curing, right? Fine. So basically what we do in laboratory, we will be immersing that specimens into the water completely. Once you prepare a concrete, if you place it in standard molds, after taking it out from the mold, we have to immerse completely into the water. You might have seen those things in the laboratory, right? So that enough water will be there for the cement so that the CSS gel forms and it is going to make the concrete to be a stronger material. Okay, I hope you understand this. Now let us understand one more thing. Okay, so after 28 days of curing, we test them. What are the size of the specimen we have to use for testing cement mortar? If you want to test cement mortar,
150 centimeter cube, sir.
What is that?
150 centimeter cube.
No. So please understand, my question is, it's not concrete, it's a cement mortar. If it is a concrete, we use that 150 cube. So it is cement mortar. I'm talking about cement mortar, not concrete. So we'll be using 70.71 cube. This question asked in the exam, in the GATE exam earlier for 1 mark. The size of the cube used for testing the cement mortar is, the size of the cube. Cube means all dimensions are same, equal. So this and this. So please try to understand, this is what the cube is. So cube has all dimensions of same size. Everywhere you take it, it is 70.71 size. Okay, I hope you understand this. Now you take minimum. What is the meaning of sample? Our Indian standard is saying that one sample means 3 specimens at least. You look at any incident happens, any crime happens, any kind of thing happens in society. For example, something has happened. So if one person says, then nobody can come to a conclusion. That one person may be lying also. We don't know. That's why we take the help of 3 people. If 3 people are saying, different people are saying that same information, then people, police official, for example, there is any kind of small accident, whatever it is, incident happened. The police officials, they come to no conclusion when 2 or 3 people, if they say same information, then they suspect that it may be correct. Okay, they come to a conclusion that it may be correct. but they don't believe only 1%. Right? Basically, it's like that. Cement mortar strength also, if you want to estimate, we never depend upon one specimen. So we need to have at least 3 specimens. That is what our Indian standard is saying that. So to suppose if you have a class, in a class, if there are only 2 students, then one must be first students. Out of those 2, one will be the first, one will be the second. We cannot compare them. If the third fellow is there, we can compare. This fellow is better than this. This fellow, when compared to this, that fellow is good. That comparison is made when you have only 3 people in a class. Do you understand that? That's what. See, to get the proper strength attainment, we need to have at least 3 specimens. Our Indian standard is saying that at least 3 specimens. It may be concrete also, but size of the mold may be different. For cement mortar, we are using this size, 70.71 mm size. If it is a concrete, we go for 150 mm size, likewise. Okay, but what is the basic fundamental is at least 3 specimens we have to cast. At least 3 specimens should be cast. At least 3 specimens should be cast to determine the strength. So what we do is, once you prepare the cement mortar by mixing cement and sand in the proportion of how much? Cement and sand are mixed in the proportion of 1:3. Then by adding a water, how much is the water we need to add? The amount of water to be added is P/4 plus 3% by weight of cement and sand together. What is P here? Standard consistency of the cement that can be tested using standard standard apparatus called as Vicat apparatus. We'll get for the cement, and we will be adding that amount of water to the cement. Then we get the cement mortar. Fine. Now let us understand, students. Once you prepare the cement mortar, we place that cement mortar. This is the cement mortar. Let's say prepared in a container that we are going to place in 3 cubes and cure them for 28 days. After 28 days of curing, we take them from the curing tank. Then we test them under compression. Then we will be getting the, what we can say, the strength of the actual cement. Okay, I hope you understand this. So 1 minute, students, give me 1 minute. Yeah, students, yeah. Can you hear me? Am I audible to you, students? Yes. Am I audible or not? Any one of you?
Yes, sir.
Okay, fine. That's it. So at least 3 specimens, we test them under compression. We have to test them under compression. Then we have to find the loaded failure. Let's say P1 is the loaded failure of first specimen. P2 is the loaded failure of second specimen. P3 is the loaded failure of third specimen. Then these are only loaded failures, but we have to estimate stress at failure. Sigma 1, Sigma 2, Sigma 3. Just I'm telling you methodology. Same thing is applied for concrete also. Okay. So now look at here. So what is the stress? Force by area. So loaded failure of first specimen by cross-sectional area will give Sigma 1. Sigma 2 means P2 by A. Loaded failure of second specimen by area. Loaded failure of third specimen by area will give you the Sigma 3. Now, what is the strength of the entire mix means? Average, Sigma average. So we need to do average strength of the 3 specimens. That will be the actual strength of the mix that is given. That is actually recommended by Indian standard. So we find 3 specimen strength sigma 1, sigma 2 plus sigma 3 by 3. That will give you the average strength. That average strength itself is going to decide the true strength of the entire mix. It is a mix. It is a mixture of 3 materials, right? Cement, sand, and water. The strength of a particular mix is nothing but the average of 3 specimens tested under compression at how many days of curing? At 28 days of curing, right? Please try to understand. This methodology is applicable for concrete also, but for concrete we use 150 mm cube, but for cement mortar we use the 70.71 mm cube. Okay, I hope you understand this. Now, if this sigma average, if you find, and if you get that value as not less than 33 megapascal, megapascal means Newton per mm square, to 42.99 megapascal. If you are able to get this stress range, then we can say that grade of cement as OPC 33 grade cement. When do you say cement as a OPC 33 grade cement? If the strength, whatever we got it, if that is there in the range of 33 megapascal to 42.99 megapascal, then we can say that that cement as is the OPC 33 grade cement. If sigma average, whatever you got it, if that value is found to be not less than 43 megapascal to we can say 52.99 megapascal. Megapascal means Newton per mm square. Then that grade of cement is called as the OPC OPC 43 grade cement. The strength is not less than 53 megapascal. It may be more than 3 megapascal. Then that is what we call as OPC 53 grade cement. So these are the 3 grades of cement we are having for the construction purpose. But nowadays this OPC 33 grade cement is outdated. We are not using for construction. We are going generally using with 43 and 53. Mostly we are using 53 grade of cement for construction purpose. I hope it is clear for cement. Regarding cement, it is clear to you. Okay, fine. And next one is water. If you want to use water for concrete preparation, there are some requirements we need to have satisfy. What are the requirements for water? Can you use, what kind of water you use for concrete? Can you please tell me? What kind of water we use for concrete? Can you use mineral water? Can you use Kinley, Bisleri, that kind of water? Or what is the standardization basically? So if you want to use a water for concrete, it should be a potable water. What water we have to use? Potable water should be used for concrete preparation. Potable means we can say which is fit for drinking. It may not be containing essential minerals, but it's almost fit for drinking. And provided that the pH value of the water should not be less than 6. pH value of the water should not be less than 6. Such kind of water only we use for concrete preparation. Please try to understand this. So it's a very, very important point asked in competitive examinations, different competitive examinations. So potable water, and the requirement is the water should have a pH value more than 6. That water only is used for concrete preparation. Please remember this. And it does not contain any kind of harmful substances. Okay, then only we can call it as the potable water. Please remember that. And the permissible limits for different substances in water, if you see, our Indian standard is saying that there are some questions appeared in GATE and engineering service examination based on this. That is what we call permissible limits for a substance in water. Let us see that. There are some questions asked based on this. Permissible limits for substance in water. So don't worry, I'll explain about cement fundamentals now very clearly in building materials. You will be learning that. Otherwise, you will be losing interest if I start explaining about that theory part. That will be covered separately in building materials. Don't worry about that. Now let us come to the point. What are the permissible limits for substance in water? You see, our Indian standard is saying that the water, if you want to use for concrete preparation, that concrete should have some limits for each and everything, like organic content, sulfates, chlorides, how much is the inorganic content, what are the total suspended solids. Okay, so all these, there is a limit for them. Okay, let us see one by one. So the organic matter or the organic solids also. So the organic matter or organic solids, those organic matter should basically should not be more than 200 ppm. How much? 200 ppm. ppm means parts per million, or we can say 200 milligram per liter. That means if you take 1 liter of water, maximum organic solids can be 200 milligrams, not grams, milligrams. Okay, please try to understand that. Then we have, what are the permissible limits for sulfates? So sulfates composition should not be greater than 400 milligram per liter. And we have even chlorides. Chlorides content also should not be greater than 200 milligram per liter. It's also 200 ppm. And we have even inorganic solids. The inorganic matter or inorganic solids, that inorganic matter should not be greater than 3000 ppm. How much? 3000 ppm or 3000 milligram per liter. So that is the inorganic matter. Then we have even called as total solids, total suspended solids, we can say, total impurities. People also call it as total solids or total impurities in water. The total impurities in water should not be greater than 200 ppm. 2000 ppm. ppm means milligram per liter. So there was questions asked in gate examination based on this. What are the permissible limits for chlorides in water? So chlorides water should not be greater than 200 milligram per liter. So we take 1 liter of water, in that how many milligrams of chlorides maximum possible allowed is 200. What is the maximum amount of organic solids in the water? That is also 200 milligram per liter. Sulfates, what is the maximum sulfate content we can use in water? 400 milligrams. Okay, it is for concrete preparation, not for drinking. It is only for concrete preparation purpose. Okay, I hope it is clear to every one of you, right? Now, let us understand what we call basically, this is all about the water guidelines as per the Indian standard. Now, let us see what are the different types of mixes we're having. Can you please tell me how many ways you can mix the concrete? Any one of you? How many ways you can mix the concrete? How many ways you can prepare concrete otherwise? Let us look at that so that you can have some idea about that. So types of concrete mixes. How many ways the concrete mix can be prepared? So we have nominal mix, we have standard mix, we have design mix. So concrete mix can be done in 3 ways. One is called as the nominal mix. Can you please tell me what is the meaning of nominal mix? Can anybody tell what is the meaning of nominal mix? Yes. Listen, very simple thing. Concrete is what? You know, that mixture of cement, fine aggregate, coarse aggregate, and water. How do you measure the quantities? Can you please tell me how do you measure a quantity of materials? Cement quantity, fine aggregate quantity, coarse aggregate quantity, water quantity. How do you measure
Sir,
it?
using rates of concrete, sir.
No. I'm talking, okay, listen, I'm not talking about the proportion. I'm talking about measurement. How do you measure your weight? Basically, in terms of kgs, right? Yes? Yes or no? How do you measure your weight? you will be standing on weighing machine. It will be displaying some reading, right? That is what we call way of measuring. Likewise, how do you measure cement? That's what we call batching. What we call batching. Batching means measuring certain quantity is called as the batching. So batching of material can be done in two ways. One is weight batching. In terms of weight, we measure the quantity. The second one is the what we basically call as the volumetric batching. So look at outside. Most of the time, villages and all you can find. How do they mix the concrete? Can you please tell me how do they mix the concrete? They'll take containers basically. One container of sand. Okay. One container of cement and 3 containers of sand and 5 containers of coarse aggregate. Have you seen that? How they are mixing outside, especially small quantity of works, manual mixing. Have you seen? That's what we call volumetric batching. They take some containers, these many containers of cement, these many containers of fine aggregate, these many containers of coarse aggregate. In terms of some kind of what we call, I don't know your local language, I don't know exactly. A container they take it, workers, okay, on their head they keep it and they throw into the mixture. I think you realize what I am trying to say, right? I hope you understand. That's what we call volumetric batching. What is the meaning of weight batching? Just to take cement and keep it on a weighing machine, how many kgs of cement, how many kg of coarse aggregate, how many kg of fine aggregate. If you are measuring in terms of weighing machine, that becomes a weight batching. So batching can be done in two ways. One is the weight batching, the other one is the volumetric batching. So nominal mix means in nominal mix, there are some fixed proportions for ingredients of concrete. For example, you take M, what is the least grade of concrete possible? Can you please guess? What is the least grade concrete?
M5, sir.
Yes, very good. M5 grade concrete. Very good. Then after that, M5, then we have next what? So we have M5 grade, we have M7.5 grade. Then after that, we have M10 grade, we have M15 grade, and we have M20 grade, and so on. Okay. Now let us see what is the meaning of M and what is the meaning of the suffix number. M refers to mix and the number refers to the characteristic compressive strength of the concrete. Okay, that is what I'll explain what is the characteristic compressive strength very clearly later. But M refers to mix here, number refers to characteristic compressive strength of the concrete, which is tested at 28 days of curing, right? Now, what are the proportions for M5 grade concrete? If I say M5 grade concrete, it has 1:5:10. If you mix cement, fine aggregate, coarse aggregate in 1:5, this listen. But what is the meaning of first? So cement is the first ingredient for us. Fine aggregate is the second. Coarse aggregate is the third. Okay. Now, if you take M7.5, how do you get it? It is the proportion of 1:4:8. What is the proportion of M10? It is the 1:3:6. What is M15 grade concrete? How do you get M15 grade concrete? It is the proportion of 1:2:4. That means 1 parts of cement, 2 parts of sand, and 4 parts of coarse aggregate. But the M20 grade concrete is 1:1.5:3. That will be becoming a M20 grade concrete. So please try to understand. And nowhere we use the water in the mix proportion. So water is not expressed in the mixes basically, but water is decided. Water is added in the form of water cement ratio. Water is added in the form of water cement ratio. And that water content is decided according to the requirement of strength and workability. According to the nature of work, type of construction, importance of the construction, we decide the workability and strength aspect. according to our given workability and according to the required strength, we will be deciding the how much amount of water we have to add based on the water cement ratio. Okay, basically, right? You please try to understand that. Okay, now let us understand, students. What is the workability needs? For example, if you want to pump the concrete to 10-story building, it should have good amount of water content. Then only it will have proper uh, fluidity. Otherwise, we need to add some chemicals, super plastages, okay, etc. We have to use admixtures in order to make more fluidity without compromising with the strength. Okay, fine. So according to the requirement of workability, we are going to decide water content. According to the strength requirement, also we decide the water cement ratio. There nobody can say this much amount of water for these mixes. For these mixes, we have only Indian standard is saying that we have proportions of cement, fine aggregate, and coarse aggregate, but water content is to the discretion of the particular civil engineering. So directly code is not saying any information about how much amount of water to be added. Otherwise, people will blame the code. So that's why code writers, they're very, very, intelligent people. They don't give statements wherever there is ambiguity. Whenever there is ambiguity, they don't say any statement, because otherwise people go for legal actions. They go to the court. It is written in code, we followed, but the structure is failed. That's why whenever there is some discrepancy, people says, the code is silent. That's what you have to understand. Okay. So you should make appropriate decisions according to the requirement. I hope you understand this. Any doubts as of now? Any questions? Is it clear? If I want to grade M5 grade concrete, I have to take 1 part of cement, 5 parts of fine aggregate, 10 parts of coarse aggregate, like that any concrete. Now listen, but nominal mix, what happened is there are fixed proportions here. What are the advantage of this? There are fixed proportions. 1 minute. There are fixed proportions of materials for a particular grade. There are fixed proportions of materials for a particular grade like this, but nominal mix is applicable only up to M20 grade concrete. Please make an understanding of this. It's a very important point is that you cannot prepare M30 grade concrete or M50 grade concrete. Okay. Is it clear? We cannot prepare M50 grade concrete with nominal mix. There is no guideline. So nominal mix maximum it is valid up to M20 only. Okay. Beyond M20, if you want to have M25, M30, you have to do design mix. Okay. We have third, that is what we call design mix. I'll explain very clearly there. Okay, fine. Is it clear? Nominal mix is valid only up to M20. Please make a note of this. Now, one more important thing is that in nominal mix, weigh batching is adopted. It's a very, very important point. Make a note that in nominal mix, what kind of batching is adopted is that it is, volumetric batching. What batching it is? Volumetric batching is adopted. What kind of batching? So volumetric batching is adopted in the nominal mix. So every quantity for a particular mix is obtained by volumetric batching, but not by weight. It is by volume. I hope you understand this. Now let us understand. There is one more mix called as the standard mix. What is that? Standard mix. There's no difference. Everything is same. Nominal mix and standard mix both are same, except there is only one change. That only one change is that weigh batching. Everything is same. All these proportions are valid even for the standard mix. But in the standard mix, our Indian standard is saying that you have to measure every quantity in terms of weight. But nominal mix is followed which one? Volumetric batching. We have the second type of mix called as the standard mix. Let me talk about here. Standard mix. Standard mix also valid up to 120 M20 grade concrete, valid up to M20, and but only difference is that it is what kind of batching is adopted. Wave batching is adopted here. So wave batching is adopted in this case. I hope you understand. Standard mix uses the wave batching and nominal mix adopt the volumetric batching. So I hope it is clear to every one of you, right? Now let us understand design mix. What is the meaning of design mix? So this is very, very important for us. Being a civil engineer, we should know about this. The design mix. In design mix, there are no fixed proportions. Standard mix also proportions are same. If you want to get M5 in standard mix, it's nothing but 1:5:10. If you want to get M10, 1:3. It is same as nominal mix. If you want to get M20 grade concrete, it is 1:1.5:3. Okay, that is how you'll do it. It is same as previous, but only batching is wave batch. There in nominal mix, volumetric batching. It is clear. Now design mix, there are no such kind of proportions. In design mix, the designer, nothing but civil engineer, has to arrive at the appropriate proportion of cement, fine aggregate and coarse aggregate and appropriate water content. So design mix, there are no fixed proportions. Please make an understanding of this. Proper understanding is that there are no fixed proportions for design mix. There are no fixed proportions of ingredients of concrete. But how do you get those proportions? Those proportions you have to arrive at. How do you get those proportions? According to the strength requirement. Very important parameter is strength criteria. So if you want to construct a structure which should sustain heavy loads, you need to go for high strength concrete. How do you get high strength concrete? You need to go for appropriate binder content, means cement content you have to increase, and superior quality materials you have to use, and appropriate water cement ratio you have to use. If you maintain that, it will automatically becomes a high strength concrete. So proportions of these cement, fine aggregate, coarse aggregate are arrived according to the strength requirement. Please try to understand this, okay? And try to understand, as I told you, there are no fixed proportions of ingredients of concrete. There are no fixed proportions of ingredients of concrete. Please try to understand this. But proportions are arrived. But proportions are arrived at by considering strength aspect. By considering strength aspect. Proportions you are going to arrive without compromising with this strength. Please try to understand it. Now listen, as I told you, there is a term called as, in the design mix, there is a term called as target mean strength. I've heard about this. There are questions asked in the exam. Now let us understand this. Target mean strength. Do you know how to get target mean strength? What the formula for target mean strength is? The target mean strength for the concrete is given by Fm is equal to FCK plus 1.65 times standard deviation. So students, please try to understand. Don't look in terms of formula based. Just to try to understand this very clearly. Target mean strength Fm is equal to FCK plus 1.65 times sigma. This is very, very important formula for different competitive examination. In GATE exam itself, there are 3 questions asked based on this formula. So what is the target mean strength for a particular grade of concrete? The formula is Fm is equal to target mean strength Fm is equal to FCK plus 1.65 times standard deviation. Okay, please try to understand it. Now let us understand, students, why we are talking about target mean strength. Can you please guess why there's a term called a target mean strength? Suppose you are preparing for a GATE exam. There is some target you are going to plan. Yes or no? Do you have targets? Or blindly you are going? Or blindly you are preparing for GATE exam? There must be some target. Let's say you are hoping for top 100 rank, or some of you may be aiming for first rank, etc. Right? Etc. Etc. Depend upon the capability, they target something. So nothing, nobody can stop you to target something, right? Anything for that matter, not only GATE exam. In your life, what several targets may be there. So target you will be fixing, okay, but at least you will be able to arrive at minimum thing. Okay, your target, if it is less, if the target itself is very less, you will be end up with very worst case. Okay, please understand it. So that's why concrete also, I want to have M30 grade concrete. That means it should have a strength of 30 megapascal at 28 days of curing. If you want that M30, don't aim for 30 MPa. You should aim for something high. If something goes wrong, at least you will be getting 30 megapascal. That is what the thing is. So you prepare for first rank, then you end up with 100th rank, let's say. If you are aiming for 100th rank, you may be end up with 2000 rank, let's say, for example. So that's why our very basic philosophy it is applicable to human beings also, not only concrete. So our researchers told that in the Indian standard is saying that otherwise. So target mean strength should be always higher than what you are expecting. What is our expectation is FCK. What is our expectation of concrete strength? Our expectation of concrete strength is FCK, but we will be targeting for higher value. Any questions? Yeah, Karthik. Fine. So we'll close with 10-15 like that. Okay, so fine, no problem. So listen, that means, see, look at here. What is the meaning of sigma here? So here, sigma is the standard deviation basically. Sigma is the standard deviation. That standard deviation you're going to get by testing the material, right? So you look at here, basically, suppose if you have grade of concrete, in the options of data, we should take all these things. So grade of concrete. So please bear with this theory content, because without this, you cannot go further, basically. There are some questions they asked. Otherwise, you can really enjoy the design. It is very interesting. But the first class, you have to bear with the basic fundamentals. So grade of concrete. And sigma is the standard deviation. Because it is a very late class, you may be sleepy also, there's no doubt. So try to bear with me for another 15 minutes. And this is very crucial time, and please understand that you try to spend time for the preparation. Preparation in the sense, be active in the class. That itself will be helping you to get the good score in the GATE examination. So GATE exam is the only exam which will make you to settle quickly, fastly when compared to other things. Need not to go for M.Tech, PhD and all. Just with B.Tech qualification itself, you will be able to earn some lakhs of rupees. Okay, so that is the beauty of opportunity you are having now. Just to try to make use of that. Fine, come to the point. So grade of concrete, if you take M10 and M15, for M10 and M15, the standard deviation is 3.5 megapascal. How much? 3.5 megapascal. If it is M20 and M25, then the standard deviation is 4 megapascal. If it is more than or equal to M30, the standard deviation is taken as 5. Please remember, this is a very important table. Based on this, many GATE questions are appeared. GATE and other examinations also, they ask the questions based on this. So target mean strength. See, listen, if I say M30, what is the meaning of M30? This number 30 is what we call FCK. That FCK, what is the symbol FCK means? Characteristic compressive strength. Any grade, suppose if it is M20, what is the FCK for M20? Nothing but 20 megapascal. So FCK is 30. Our aim is 30, but we target for high. Okay. Our achievable thing is 30 minimum, but we will target for high. That's what the meaning of target means. And sigma is the term, is nothing but standard deviation. It depends upon the material quality. So material to material, there are many parameters will be governing, mixing, compaction, everything. That will be nothing but varying the material strength that we are going to measure with a parameter called as standard deviation. And 1.65 is a Kismet constant that is given by Indian standard just to have some higher effects of any kind of what we can say imperfections in the material that will be taken care by this 1.65 times standard deviation. That is all. So one of the question asked in the GATE exam is, fine, what is the target? This is the question asked in the exam. Can you answer this question, all of you? What is the target mean strength? What is the target mean strength for M30 grade concrete? Can you please answer this question, all of you? What is the target mean strength for M30 grade concrete? They given different options. Can you please tell me? What is the target mean strength for M30 grade concrete?
38.25.
Yeah. How would you get that? Very simple. Let's look at solution for this. Any other answer from students? So target mean strength FM is equal to FCK plus 1.65 times sigma. Our Indian standard is saying that in the options of data, actually you have to get standard deviation by testing the concrete specimens. But every time you cannot go and test. That's why our Indian standard is saying some values. And it is saying very clearly below the table that this table you have to use if there is no test data. But for the GATE exam, they cannot give you any test data to find standard deviation. That's basically, you remember this table. For the competitive examination, you remember this table. So I hope, can you remember this? All of you are able to remember this table? Please try to remember this table. For M10 and M15 grade concrete, standard deviation is 3.5 megapascal. For M20 and M25, standard deviation is 4 megapascal. Okay. So our question is M30. Either M30 or more than M30, standard deviation is 5. So now they asked for M30 grade concrete, standard deviation sigma is 5. So therefore FCK, they asked for M30. So FCK is 30 plus 1.65 times standard deviation is 5. So how much is the answer? You got it? What is the answer?
38.25.
Very good, excellent. 38.25 megapascal. What's your name?
Kavita Eeci.
Good, very good. 38.25 is the correct answer. So likewise, if they ask for M20 grade concrete, can you please tell me how much is the target mean strength for M30 grade concrete? For M30 grade concrete, what is the target mean strength?
M30 or 24?
Sorry, M20, for example.
$27.425.
Yes, exactly. Very good. 27 point something. Okay, very good. So likewise, listen. So our objective is we have to aim. Listen, if you want to get M30 grade concrete, our Indian standard itself is saying that our aim is desirable thing is M30. This is desirable, required. But we should aim for high so that because this concrete is not a homogeneous material, it is obtained by mixing different ingredients. Cement is different material. It is complete properties different, fine grade is different, coarse grade is different. What is different? A variety of materials you are mixing to get a concrete, and we cannot exactly predict what is going to happen to that material. That's why, to be on safe side, if you want to get M30, but we aim for 38.25 strength and we and we get the mixed proportions. But at the end, when you test them, minimum it should be able to bear a stress of 30 megapascal. Then we succeeded. That means, listen, we aim for target mean strength, but we should be able to end up with at least a strength of characteristic compressor strength. That is what the philosophy we are followed in Indian standard to get a particular grade of concrete. Okay. And one more very important thing is that in design mix, there are no fixed proportions. See here, in nominal mix and all, we have some fixed proportions, but here there are no fixed proportions, but fixed proportions we are going to arrive at by taking a target mean strength as the target. So we make the target for this, and accordingly we will be getting the proportions. One important thing is that in previous mixes, I told you two other mixes, nominal mix, standard mix. We are not bothered about the material properties, but in design mix, you have to first test the material. Very important thing, make a note that in design mix, properties of materials are considered. Properties of materials are considered. That means every material need to be tested in laboratory. What is the specific gravity? What is the density? What is the water absorption? What is the fineness modulus? If it is a fine aggregate, coarse aggregate, fineness modulus you have to find out. And according to the reactivity also, we are going to decide the mixed proportions. So properties of materials are considered. Suppose if it is a rainy season, you have more water content. So if there is a more water already existing, you are going to adjust the water content by taking property of materials into account. How much is the water absorption, like that, moisture content. But in standard and nominal mix, it is not there. Whatever is there outside, just to bring it and mix it. Doesn't matter whatever it is there in it. Then do you tell me which is scientific way of designing concrete mix? Which is scientific and acceptable out of all this? Is it nominal mix, standard mix, or design mix? Which is more accurate?
Design mix.
What is that?
Design mix.
Yes, very good. So design mix is well acceptable thing because you are targeting for high strength and you end up with some reasonably good strength, whatever you are going to aim for. At the same time, material properties you are testing in the lab, and accordingly you are going to adjust the properties, suppose if, especially water content, and according to the strength requirement, we are going to use the materials. This will be very scientific way of designing the concrete mix. That's why our Indian standard is saying that don't follow nominal mix beyond M20. So nominal mix can be followed maximum up to M20. But beyond M20, you have to go for design mix. Even standard mix also not valid. It is also valid up to M20. Any grade which is having M25 and above, we have to go for design mix. Even for M20 also, our grade is our IS 456 saying that better to go for the design mix, even for M20 also. Including M20 and more than that also, it is preferable to go with the design mix. So design mix is valid more than or equal to M20 grade concrete. Can you please tell me what is the minimum grade you have to use for RCC structures? Any RCC building you want to construct in India, what is the minimum grade you have to go? Can you go with M5, M10? What is that? Can you please tell me? Huh? What is the question I asked? Can you please answer? What is the minimum grade of concrete you have to use for RCC structures in India? Minimum grade. Can you use M30 minimum or M5? What is the minimum grade? Any RCC structure you want to construct, the minimum grade of concrete is M20. Very, very important question asked in several competitive examinations. I'll explain that after this. Minimum, I write here otherwise. Minimum grade of concrete. Minimum grade of concrete for RCC structures. So minimum grade of concrete for RCC structures is not less than M20. You can use M20 or above, but not less than M20. That's why which mix you have to prefer then? Any RCC structure you want to construct, you have to go for the design mix. There's no option. You have to go for the design mix, right? So, okay then. So, shall I stop here? I'll stop here then. Any questions before I stop? Any questions are there, students? You can ask me. Any one of you? Any questions so far? Is it clear to everyone? Listen, what I told in today's class, let me summarize in 2 minutes. Then we'll wind up the class. Okay. So I explained about what is a concrete, what are the function of different ingredients of concrete. I explained what are the different grades of cements we're having. Okay. What are the proportions for cement mortar, standard cement mortar? This is also asked in GATE exam once. 1:3 is the proportion of cement and sand in case of standard cement mortar. Amount of water to be added for standard cement mortar is P/4 plus 3%. P is the standard consistency. This is only for testing purpose. What kind of testing? To decide the grade of cement. So minimum how many specimens you have to cast? 3 specimens should be cast to determine the strength, and the average of those strengths will be the true strength of the particular cement mortar mix. And according to the average strength, we decide the 33 grade or 43 or 53 grade cement. Okay. A very important point is that, let me tell you students, why strength is increasing from 33, 43, 53 like that? Why strength is increasing? Any reason? Do you think any reason is there? Why we are having, why don't we have only one grade of cement? Why we have 33, 43, 53? How we are able to get them? Can you guess something? I'm asking question to you, students. Any reason may be there? What may be the reason?
So according to the type of structure, we'll use different grades.
Can you please come again?
Like, according to the type of structure,
Okay.
the grade will be used differently.
No. Okay. Fine. So you're not okay. You're answering is in different way, but my question is, how you can get 33, 43, 50? That is what I'm asking. You can use it for different structures, different grade. That's fine. That is okay, fine.
Okay.
But I am asking you, how you're able to get 33, 43, 53 grade? Do you think that everything is same, or are you changing some? Are you adding some chemicals to get 53 grade when compared to 43? Which is having highest strength? 53 grade is having maximum strength. 33 grade is the least strength. What is the reason how you can arrive 43 and 53 when compared to 33? You are getting more strength. How you are able to get that? Please don't think that students material composition is not changing here. Only reason is that. What is the only reason? Can you guess something? First you guess. I want you to think. Students, very important thing is, especially in IITs and all, the students has to think more. Whether it is wrong or right doesn't matter. If you have that thinking capacity, you can sustain in any situation, any circumstance in your life also. If you have proper skills of thinking, how to overcome the problems, how it is, why it is, this kind of skills if you have, you can survive in your real life also very easily. You can get good job also if you have that analytical skills. Analytical skills are very, very important. Every engineer should have that skill, basically. Why? Okay. Why I'm asking you why you are able to get high strength. Only reason is that binding is very important parameter. So which is grinded more? Which material is grinded more here? 53 grade cement is grinded more several times, which is the finest material. That's why it is able to get the high strength. Least fine material is 33 grade cement. In that, we will be having very least fine material. In the manufacturing of cement, we will be using ball mill. That ball mill is going to make the materials to powder. We will be having argillaceous material, calcareous material for cement production purpose. Limestone and clay are mixed. Limestones are to be powdered to very, very fine material by adding gypsum at the end. But the is very done very long period, it becomes a very fine powder. That very fine powder is going to occupy the micro voids also. Then you get the highest strength. Okay. So which matters here? Highest grade of concrete cement means it is grinded more time. It is having very fine materials. That's why it is able to give high strength. Okay, grinding matters. So which is costlier among these three, 33 grade cement or 53 grade cement or 43? Which is costlier cement rate wise also when you purchase?
53.
Yes, obviously. Why? Because in the ball mill, they have to operate for a long time to get the finest particles. Then finest particles will give more strength. For that, it consumes more electricity or more fuel consumption. More fuel consumption, more rate they charge it. That's it. Very simple. So fineness matters here. So more fineness, more will be the strength. Fine. So minimum how many specimens you have to cast? 3 specimens. So what are the limits for water? Organic matter how much? Sulfates how much? Chlorides how much? If you want to use, not for drinking purpose, it is for concrete purpose. Drinking water standards, I have already explained in environmental engineering, right? Earlier, in offline classes and all, I told that is for drinking water. Now look at here, types of concrete mixes. We have nominal mix and what are the proportions? We are using volumetric batching here. If it is the standard mix, we'll be adopting only weight batching here. That's the only difference. Proportions are same. We have design mix. For more than or equal to M20, you have to go for design mix. Design mix is based on target mean strength. Here we consider the properties of the materials. That's the summary of the whole class. So we'll see the very interesting things in the next class. This is a very basic introductory class. That's why I explained the basic fundamentals. From next class onwards, we'll be really going into the subject. Is it fine? Any questions? Can I stop here? Any questions from your end? Is highly appreciable. No questions? Yes. Students, any questions? If there are no questions, say no questions.
No, sir.
Fine. Okay, then. Thank you all. We'll meet in the next class. Thank you all.
Thank you, sir.
Welcome. Bye. Parthasarathi. Okay, then. So I'm stopping the meeting. Thank you all.